Hi, and welcome to Lesson 3.4, Proofs with Perpendicular Lines. Now, we are on page 81, and before we start, make sure that you guys have your compass and your protractor. Also, make sure that you guys get a half sheet of blank paper, and I want you guys to glue one on page 81 and page 82. So the first construction that we're going to do on page 81, it's going to be titled Perpendicular Line through a point not on the line. Okay, so it's going to be called Perpendicular Line through point not on the line. Okay. Now we're actually going to be doing a second one called the perpendicular bisector. Okay, so in order to do that, we're going to need to split this into two different parts. Okay, so we're going to do the perpendicular bisector. Okay, now the first one that we said we were going to do is a perpendicular line through a point not on the line. We are going to have the perpendicular bisector, and there is actually a third one that we're going to do. If you guys quickly turn to the next page where you glued the second one, is we are going to be doing the construction for the perpendicular through a point on the line. Okay, so that's the one that we're going to do. Okay, so let's go ahead and go back to page 81. And let's start first. Let's start here at the bottom. Let's start with the perpendicular bisector. Okay, now first thing you need to do is you need to create a segment down here at the bottom. The length of it doesn't really matter. Don't make it too small though. And I would kind of draw this kind of towards in the middle. Okay, so here's your segment, and I'm going to call this segment A, B. Now this construction is going to allow me to find the midpoint and to draw a line that is going to be perpendicular to AB and going through the midpoint. Okay, so here's what you're going to do. And guys, there are tons of videos on how to do a perpendicular bisector. Okay, so this one's mine. If you need additional ones, I'm pretty sure there's tons that you guys can go on YouTube and figure out how to do this. Okay, so for the perpendicular bisector, you're going to need your compass. Now, when you guys are using your compass, you need to make sure that you open up your compass to a distance that is at least a little bit more than halfway. So for example, this would be too small. This would be almost enough. So maybe just a little bit more. All I got to make sure is that my distance is at least more than halfway. Okay, so this is more than halfway. So halfway is approximately right there. So what you're going to do is you're going to draw an arc from both A and from B. So make sure you're seated and make sure that you guys are in a flat location. You know, your paper's on a flat surface, because you're going to need to turn this around. So from B, I'm going to draw an arc that is probably a little bit less than a half circle, kind of like this. Okay, so like this and like this. Now I did it from B. Now I'm going to do it from A. Okay, so yeah, you can turn your paper around. It's okay. Okay, like this. Now you're going to do that until you have two intersections. Now the same distance from B to here is the same distance as from A to here. I kept the same distance, the same radius. So now what we have here is we have these little intersections right there. You're going to grab your protractor and you're going to line up those two intersections as best as you can, like this. And then simply draw a line through those two intersections. Now this point right here, it's going to be the midpoint between A and B. So I'm going to call that midpoint M. And what we have now is we have segment AM congruent to segment MB. So we have AM congruent to MB. Okay, so that's one thing that we have. The other thing is that we have that line that we're going to call that line L. Okay, so we have line L perpendicular to line AB, or segment AB, because we made it a segment. Okay, and it's perpendicular at point M. So that is going to be perpendicular. So we call this the perpendicular bisector. Now, if you want to replay the construction, go ahead and do that. Pause it, go back to the place where you need to see it again, and do it again. Okay, there are tons of videos on YouTube on how to do a perpendicular bisector of a segment. Okay, the next one is a little bit more challenging. It's called the perpendicular line through a point not on the line. Okay, so I want you to draw a line. Okay, you're going to do it kind of like a little bit above. Okay, and my point is going to be below the line. Now, if your point happens to be above the line, the construction is the same way, guys. Just turn it upside down and do it the same way. Okay, so I'm going to do it where my point is below the line. Okay, but if it's on the other side, just turn the paper upside down and do the same thing. Okay, so here's what you're going to do. You're going to open up your compass. You're going to put your metal piece on that point. I'm going to call that point, I don't know, A. Okay, you're going to put your metal piece on A, and you're going to open it up just enough to go past the line. Because this right here, this is too short. This right here, where it's at the line, too short. Gotta make it a little bit bigger, not too big, because then that's gonna be, you know, very off of the line, and when you do your intersection, it may not even hit those you know, the line. So make it go just a little bit above it, like this. This is a good distance. Okay, so what you're gonna do is you're going to lean your compass forward and draw an arc that intersects that line at two locations. Okay, here and here. Now, you could keep the same distance if you like, okay, or make it a little bit smaller. Okay, so from here, I probably should have done this a little bit lower, okay? So I'm going to close it just a bit. I just got to make sure it's a little bit more than halfway from here. So from here, I'm going to draw an arc like this and do it from this other endpoint like that. Okay, so where did I get these two? I got them from here and here. And now what you're going to do is you're going to look at that point of intersection right here and line it up to A. Okay, like this. Okay, and what this does is that this is going to be a perpendicular line. Now I'm going to call, I can extend the line if I wanted to. You don't have to. I'm going to call this line, I don't know, B. Okay, so here, line AB is perpendicular to line, I'll call it up. Okay. Now, this point isn't necessarily the midway between these two because remember, this is an infinite line. So this is the perpendicular line through a point not on the line. Now, on the back, we're going to do the one where the point is on the line. Okay? So that's on page 82. Okay, so right now, if you need to go back and see this construction again, pause it, go back and see it again. Let's look at page 82. And here we're going to do the perpendicular through a point on the line. Okay, so you're going to draw a line. Okay, and we're going to put a, excuse me, you're going to put a point, doesn't really matter where. I'm going to put it about right there. I'm going to call that A. Now, I'm going to open up my compass, just big enough so that I can make two arcs hitting on both sides of A. Kind of like if A was the center of my circle. Okay, so from A, about this much, I'm drawing an arc here. And then I'm drawing an arc here. A lot of people want to do like the full circle. Yo, you don't need the full circle, just a little bit. Now, here's where it's important. You have to open up your compass just a little bit because right now this is the same distance. So open it up just a little bit. If you want to make it bigger, go ahead. Okay. So from here, you're going to draw an arc. Okay, from here, and then from here again. Hence now you have this intersection and this point right there. So line them up and draw your line. Hence now this is perpendicular. And I can call this B, call this line L. And you have L perpendicular to AB. Okay? Now, there's one thing that I want to mention, and it's from the previous construction. So let's go back to the previous construction really quickly. All right, so here's the thing, okay? If I were to analyze the distance between the line and this point, you're going to see that it's going to be a lot of different lengths, okay? If I were to draw the line from here to here, or from here to here, or from here to there, they're all going to be very different, okay? But the thing is that the shortest distance happens to be the distance from here to the perpendicular. So if I were to call this point here C, okay, distance AC is the shortest distance to line L. Okay, so what does that mean? Okay, if I were to pick a point right here, right where my finger's at, the distance from here to here is going to be a lot greater than the distance from here to, say, here. And then here, and then here. So the shortest distance is always a straight line perpendicular to that. I'm mentioning this because you are going to need that in just a bit. Okay? All right. So let's go on to page 83. Okay, please write down where the problems are going to go. Okay, so number 1's going to go right there. Number 2 and 3 are going to go down there. Now let's take a look at our first theorem. So this whole lesson has to do with, perpendicular lines. So if two lines intersect to form a linear pair of congruent angles. Let's read that again. A linear pair of congruent angles. Then the lines are going to be perpendicular. And look, guys, it makes total sense. If these two are both a linear pair and congruent, well, what are the only two angles that can add up to 180 degrees and be the same? 90 plus 90. If it's a 90-degree angle, then it's going to be a right angle. If it's a right angle, that means that this line is going to be perpendicular. Okay, so it's called a linear pair perpendicular postulate. If two lines intersect to form a linear pair of congruent angles, then the lines are going to be perpendicular. Now, on this one, it says in a plane, because remember, parallel lines are in a plane, if a transversal is perpendicular to one of the two parallel lines, then it is perpendicular to the other. What does that mean? It means this. If, say you have these two lines right there, and you have a perpendicular that is perpendicular to the first line, well then that line J is going to be perpendicular to the second line. So it will imply that that angle is also going to be a right angle. And it's a very, very easy way to prove it if they were to ask us to do that. So that is where example 3 is going to go. Okay. Now turn to page 84 and let's look at this next one. It says in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So here you have two lines that are perpendicular to the same line, therefore they're going to be congruent to each other and parallel. So we would be using the converse of the corresponding angle theorem on this one if they wanted me to prove this. Okay, so let's go ahead and start our first example. Okay, all right, let's start with example number 1. Okay, so number 1, in the construction that we have done, we talked about what is the shortest distance from a point to a line. So you have A that has 3 segments going to the line, B, C, and D. Okay, so the shortest distance happens to be the one that's perpendicular to it. So these two, they're confusing you. Okay, the shortest distance is AC. Okay, so what we need to find out is what is the distance of segment AC. So we have the coordinates, okay, A happens to be -3, 3, and C happens to be 1, -1. So what tool do we have that's going to help me find the distance between 2 points? The distance formula. Nothing new. We have used the distance formula before. I told you it was going to come back again. Okay, so remember, x2 minus x1, y2 minus y1. That's the distance formula, and that's the one that we are going to use. So all we got to do, guys, is we need to plug the values in. Okay, so the distance is the differences of the x's. So I'm going to say that this is my x2, x1, or it doesn't really matter which one you do it. So 3 minus -1, 3 minus -1, -3 minus 1, -3 minus 1. Okay, 3 minus -1, that turns into addition, so that is 4 squared. -3 minus 1, that is -4 squared. So that's going to give me 16 plus 16, which is the square root of 32. Now, if I put that into the calculator, let me see what I would get. So the square root of 32 to the nearest 10th is going to be approximately 5.7. So always pay attention to see how they want you to round this up. Okay, so what we just did is we found the distance from A to C, because that is the shortest distance because it is a right angle right there. Okay, so that is example number 1. Let's look at example number 2. Okay, use the diagram to prove the perpendicular transversal theorem. Okay, so what we have is a set of parallel lines cut by a transversal, and J is perpendicular to H. And what I need to do is I need to show that J is perpendicular to line K. So what we're going to do is we're going to be doing a proof. Okay, so what is given? In this case, what is given is that H is parallel to K, and that line J is perpendicular to line H. And what we need to do is we need to prove that J is also going to be perpendicular to line K. Okay, so that's a J, by the way. So that is what we need to prove. Okay, our proof is not that long. It's only like 6 steps. All right, so let's begin. Okay, first step. H parallel to K, J perpendicular to H. That is given to us. Now, what does it mean for J to be perpendicular to H? Okay, well, because they're perpendicular, the measure of angle 2 is going to be 90 degrees. Okay, so the measure of angle 2 equals 90 degrees. And that's just simply the definition of a perpendicular line. Definition of perpendicular lines. Now, because H and K are parallel, then the relationship between angles 2 and 6 is that they're corresponding and congruent. So we know that angle 2 is congruent to angle 6. Okay, why? Because of the corresponding angle theorem. Okay, corresponding angle theorem says that those two are congruent. So here's the thing. If those two angles happen to be congruent, then their measurements must be the same. So the measure of angle 2 equals the measure of angle 6. Definition of congruent angles. Now, go back to step 2. Okay? If the measure of angle 2 equals the measure of angle 6, and the measure of angle 2 equals the measure of angle 90, by the transitive property of congruence, the measure of angle 6 must also equal 90. Okay, transitive property, not of congruence, I take that back, of equality, the measure of angle 6 must be 90. And if the measure of angle 6 is 90, that means that it's a right angle. Therefore, by definition, J must be perpendicular to K. Definition of perpendicular lines. All right, make sure you guys are finishing up copying this angle. If you need more time, pause the video before moving on. All right, let's look at example number 3. Okay, if it's probably a little bit difficult to see this diagram right here because in your book, it's in your book, by the way, it's on page 151. It says the photo shows the layout of the neighborhood. Determine which lines, if any, must be parallel to the given diagram. Okay, so maybe it would help if I draw this without the city. Give me 1 second. Let me draw this without the picture. Okay, that was fast. All right, so the question's asking, determine which lines, if any, must be parallel. So remember, if two lines are perpendicular to the same line, then they must be parallel. So let's take a look at S and T. Both of these lines are perpendicular to the same line Q. So therefore, S is going to be parallel to T. Now looking at it this way, both P and Q are perpendicular to line S. So therefore, P and Q are going to be parallel as well. Okay, and that's the last example. So please make sure that you guys are working on your extra practice. Okay, and we will see you all later.